function generator produces an electrical signal which can be used to characterize or analyze an electrical or electronic circuit. They're widely used in electronic design, testing and troubleshooting applications, and even have their artistic uses. They're also described as signal, tone or waveform generators, different names but the same device, the function generator. Function generators can be either analog or digital devices. Digital function generators allow the programming and synthesis of various waveforms that are not generally available on the analog signal generator. They also provide more convenient control features. Both analog and digital function generators are used in the labs. This video focuses on the digital function generator. The basic skills and techniques demonstrated here are transferable and are useful when operating either type of function generator. Before starting work, always make sure the equipment has been checked for electrical safety. The generators are checked regularly to make them safe to use. The green label should confirm this. To connect the generator to other circuits, you can use a variety of cables. Normally BNC coaxial cables are used. This is a cable with BNC connectors at both ends, or a BNC connection at one end and crocodile clips at the other. The coaxial cable has an inner core insulated from an outer shield. The shield is connected to the black lead, or the external ring of the BNC, and this connects to ground or 0 volt point in the circuit. The central core is connected to the center pin of the BNC connector, also associated with the red lead. This is the connection made to the point of interest in the test circuit. The function generator is calibrated to use test leads, which have an impedance of 50 ohms. Check the leads are correct before making connections. The impedance is usually marked on the cable. Always remember to connect both the black and red leads to the circuit being tested. Here, the function generator is connected directly to an oscilloscope. If you want to know more about the oscilloscope, please visit the relevant section of the video. Make sure the tilt stands are set up comfortably so the controls are easy to access and that the display is clearly visible. Switch on the function generator and the oscilloscope. The function generator starts up in the last state which it was used. Various parameters of the function generator can be used to make changes in the output signal. The output signal can be seen directly on the oscilloscope's display. In this example, the function generator is producing a sine wave, seen here. To adjust the sine wave, choose a frequency and amplitude. Choose a sine wave by pressing the button labelled Wave until a sine wave is shown on the display on the function generator. A frequency of 1 kHz is selected, which means the signal will repeat 1,000 times a second. To set the frequency, enter the digits on the numerical pad. Press button 1 and the kilohertz button to set this frequency. The function generator can produce frequencies up to 2 MHz. Here the amplitude is set to 4 volts. The amplitude control is used to set the magnitude of the signal. That's how much energy it contains. This generator can generate amplitudes between 1 and 10 volts peak to peak. Pulling out this control instantly reduces the voltage by a factor of 100. The DC offset controls the voltage point around which the sine wave oscillates. As the voltage is increased from 0 to 5 volts, the trace on the oscilloscope also moves up from 0 to 5 volts, and the amplitude remains the same. To change any of the preset values, this large dial is used. The cursor keys below the dial allow the position of the decimal place to change. The digits on the display will flash while changes are being made. To generate other waveforms, press the Wave button on the control panel. Here, a square wave has been selected, and this is confirmed by the trace on the oscilloscope's display. To set the frequency, enter the digits on the numeric keypad. Here, 1 and kHz have been selected to produce a 1 kHz square wave. The duty cycle can also be adjusted. This is the ratio of the time that the signal is on to the cycle period. To adjust this, press the Shift button and digit 7 on the numeric pad. The duty cycle can be adjusted between 20 and 80% using the dial shown here. It is also possible to use this function generator to produce modulated waves. It can generate amplitude modulated AM or frequency modulated FM waves. To access this function, press Shift button followed by the button marked with a decimal point to get AM, and the Shift button and numeric key 4 to get an FM wave. You can adjust the modulation parameters by using the controls labelled Sweep Span or the Shift button followed by the numeric key 5 on the front of the generator. In this case, we're using internal modulation, but it is possible to use external modulation by pressing the Shift button followed by numeric key 0 on the front of the generator. A small symbol EXT lights up on the display, showing that modulation is set to external. This function generator also features a counter mode, allowing you to determine the dominant frequency in an input signal. Here, an analog generator is used to send a signal to the digital generator. The frequency of the analog generator can now be determined using the counter function on the digital generator. To do this, we connect the main output of the analog generator to the count in channel on the digital generator. Press Shift and 1 and make sure that counter is displayed on the generator display. Now the value on the display corresponds to the frequency of the analog signal generator. As we adjust the frequency on the analog generator, it is possible to see the digital generator display the corresponding frequency. Note that the digital generator continues to supply its own signal to the oscilloscope. To switch off the function generator, first reduce the amplitude to 1 volt, then press the power button on the front panel of the function generator and switch it off at the wall. Switch off the oscilloscope. Finally, switch off the analog generator and any other electronic or electrical equipment used in a similar fashion.